Hello, this is Small Head Big Problems. I'm a small head and I've got big problems. We are back to solving and explaining 3 TMUA problems on camera with no preparation in less than 10 minutes. This is episode 4, and these are problems 10 to 12 from the 2016 paper 1. Remember, the TMUA is a multiple choice exam that does not require showing any working, so the point is to get to the correct answer as fast as possible. Hopefully, I'm showcasing the kind of speed that is required to do well. Let's go. Can you beat me to it? How many solutions of the equation x tan x equals 1 have in the interval minus 2 pi to, x between minus 2 pi to 2 pi? Okay. So what I'm going to do is divide by x on both sides. Um, yeah, obviously x will not be 0. Otherwise, x tan x is 0, so that's not a solution. So we can divide by x, no problem. Cool. Then I can just plot both of these functions on the interval minus 2 pi to 2 pi. So let's go. So tan, right? It looks like this on between pi over 2 and minus pi over 2, and then it just repeats. So this would be 3 pi over 2, and there that would be 2 pi. And there, minus 2 pi. Yeah, cool. Then 1 over x will be like that. Oh, and like this. There. Oh, like that. Okay, so we can see there's 1, 2, 3, and 4. Yep, there you go. Option E, 4. Okay, question 11. The real roots of the equation 4 to the 2x plus 12 equals 2 to the 2x plus 3 are p and q, where p is greater than q. The value of p minus q can be expressed as blah, 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 blah. Okay, so I can see that this is a hidden quadratic, right? Pretty familiar with that. Um, in the variable y equals 4 to the x. If we just make that change of variables, it'll be y squared plus 12. And let's see, this thing can be written as 2 to the 2 to the x times 2 cubed. So it'd be y squared plus 12 equals 4 to the x times 8. So y squared minus 8y plus 12 by just replacing this with y and taking it to the other side. Okay, pretty sure this can be factorized easily. Yeah, minus 6 and minus 2 multiply to minus 2 multiply to 12 and add up to minus 8. So we get y equals 2 and 6. But now we want x, right? Not y. So since y is 4 to the x, then x will be the logarithms base 4 of these. 6. Um, yeah, which by the way, the logarithm base 4 of 2 is a half because 2 is the square root of 4, right? 4 to the half. So that'd be a half. And log 4 of 6, well, not too sure. Mm, let's see. If we take the difference, so the obviously log 4 of 6 is bigger. Log 4 of 2, maybe we can bring that together using a log rule, so that's log 4 of 3. Is that somewhere? Hmm. Hmm. Do they want us to? Hmm. I mean, I'm thinking more D. Do they want us to rebase it? This is very weird. Oh, of course. I'm so sorry. So, right. Scratch all that. I mean, since they're expressing it in like terms of like log base 10, I mean, this is kind of weird and unnatural. But if we just put 4x equals y, right, where y is either 2 or 6, we can hit it with log base 10, which I'll just write log on both sides and use our log rules to say, okay, that's x log 4 equals log y. So x equals log y over log 4. Um, okay, which means um log base 10 of 4. Mm, okay, so it means like log 6 over log 4 minus log 2 over log 4. Uh, yeah, right. So log 6 minus log 2 over log 4. So using log rules, log 3 over log 4, right? 6 over 2 is 3. So it's E. Ooh. Okay. Yeah, cool. That was a bit yeah, okay, option E, log 3 over log 4. Yeah, that was a bit crazy. That really took me by surprise, this log base 10 thing. A little bit nuts. All right. A right circular cylinder is contained within a sphere of radius 3 centimeters, such a way that the whole of the circumferences of both ends of the cylinder are in contact with the sphere. Okay, I think that's sort of pretty clear from the picture, right? So we've got the sphere here. If you kind of give it a little bit of perspective. I'm sorry, the cylinder here, the base and the top base and the bottom base. Um, Diagram shows a planar cross section through the center of the sphere and cylinder. Yeah. Okay, yeah. So that, yeah, I could imagine that. So basically, like, this is 5, right? Like the radius of the sphere, which is 5, and like this is 5 as well. Okay. Find in cubic centimeters the maximum possible volume of the cylinder. Hmm. Right. Um. Hmm. What the maximum possible volume? I don't quite understand. Right. Oh, I'm sorry. Yeah, because it could be like thin. It could be uh, thin and tall, or it could be fat and um short. Okay. Oh, okay. Interesting. Right. So there's got to be a relation between like the height and the radius, right? So I mean, this is gonna be 5. And then if this is the height, then by Pythagoras, this is gonna be the square root of 5 squared minus h squared, right? So the square root of 25 minus h squared. And that height could be anything between, well, 0 and 5, basically, right? So 0 is like completely just flattened, and 5 would be like super thin and tall. Okay. So that's the radius. Now, volume of a cylinder is pi r squared times h. Um, right, so pi times, okay, right, r squared to 25 minus h squared times h. We then differentiate with respect to h, find the stationary points. Let me just expand that out a little bit. 25h minus h cubed. That'll be pi 25 minus 3h squared. To set that to 0, that gives us h equals 25 over 3, the square root of that. So 5 over the square root of 3. Um, okay. Blah, 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 blah. I mean, yeah, we just, put that back into the volume equation. So that would be pi times 25 over 3 times 5 root 3. And I suppose they want us to kind of rationalize the denominator, so multiply by 3 top and bottom. So we have I times 125 times root 3 over 9. Is that? No. What am I having? What am I getting wrong here? Oh wait, I'm sorry. H is this. Wow. And R, yeah. R squared. Sorry, so R squared is 25 minus H squared. Oof. Okay. So 25 minus 25 over 3 times 5 over 3. Okay. So instead it's 50 over 3 times 5 over root 3. So 250 root 3 over 9. Can I simplify that? No, what? 250 root 3 over 3. Ah, I don't get it. I say the most probable answer is E, but yeah, what am I doing wrong here? 3, okay. Square H. Hmm. The maximum possible volume of a cylinder. What the hell? Right. Okay. My bad. So yeah, I mean obviously the height here, that's half the height. So the volume is well twice that though, because the real height is 2h. As I've called h here. So yeah, I mean there should be a factor of 2 all throughout. It doesn't change the uh the maximizing value of h, but there's just an extra factor of 2 here throughout. So it would be 500 root 3 over 9. Uh, option E. Yep. Cool. Option E, option E, option E. All option E today. All right, great. So if you enjoyed, please make sure to like and subscribe. And if you are interested in getting private tutoring, send me a message. My details are in the description. See you next time.